Hello, I'm Dr. Michael Kessler, and I'm here with Dr. Bicchetti, and here we are for part 4, NeuroVIZR education, how the brain learns. This is probably one of the more important of the sections that we're going to go over because this kind of ties it all together for you as far as the concept.
NeuroVIZR is not intended to replace the services and/or medical advice of a licensed healthcare practitioner, nor is it meant to encourage diagnosis or treatment of disease. It is for research, education, and entertainment purposes only. Any applications of suggestions set forth in the NeuroVIZR or this training is solely at the discretion and risk of the health provider. Implementation or experimentation with any supplements, herbs, dietary changes, medication, and/or lifestyle changes, including NeuroVIZR, etc., is done so at your own risk and responsibility. It is important that you work within the scope of your professional license and state laws.
Thank you, Dr. Bicchetti. And here we go. So, this is the first concept. The brain is a predictive machine. The brain's main job is not just to react to the world, but to anticipate what will happen next. The idea comes from something called predictive processing, a leading theory in neuroscience.
The core concept is that the brain constantly builds and updates a model of the world based on past experience instead of waiting for sensory input and then processing it.
So the brain predicts what it expects to perceive via sight, sound, and touch. It compares these predictions to actually incoming sensory data, updates its model based on the difference called a predictive error or surprise. And that's one of the big principles that we're going to use to get the brain to make changes. And you'll see as we go further.
The brain strengthens models when predictions are accurate and adjusts when wrong. Neuroplastic tools like the NeuroVIZR may help reshape the patterns created by new sensory experiences and inducing beneficial prediction errors.
So how NeuroVIZR uses prediction errors to create brain change. Prediction errors are when the brain expects one thing to happen, but something else happens instead. Surprise! This mistake isn't bad. It's actually how the brain learns and rewires itself. We call this neuroplasticity. The brain updates its model of the world based on surprise or error.
What part of the NeuroVIZR does this? NeuroVIZR programs that use light and sound patterns with rhythm, variation, or unexpected shifts are triggering prediction errors. Let's explore how.
Okay, all right. Simple analogy. Think of it like learning to dance to a beat that keeps changing. Your brain has to constantly adjust. Those adjustments are predictive errors. Every time you adapt, your brain rewires a little more, creating a neuroplasticity.
For example, I walk into a dark house, but the brain knows the layout. It predicts where the furniture is based on past knowledge. If something is out of place, you stub your toe. That's a predictive error, and your brain updates its internal model of the room.
That's excellent. Now we got one more example here.
Okay.
This little girl, she's trying to ride a bike. She's never rode a bike before, right? So here she goes. And guess what? She leans a little to the left. And guess what happens? She falls. So then the brain has to make that adjustment. She leans a little bit over another way and she crashes. And finally, the brain updates its program and now she could ride a bike. Same kind of situation, right?
Yeah.
Errors or surprise to create change.
Yeah. Why does this matter? These micro surprises from NeuroVIZR, they keep the brain alert. They break habitual loops. They strengthen connections. They drive learning and recovery, especially after a traumatic brain injury, ADD, or fatigue. What happens in the brain? These sessions violate expectations the brain has about rhythm, sequence, or pattern. This triggers prediction errors or the surprise, which then spark neural updating. With repetition, this process creates lasting neuroplastic changes in sensory processing, movement, focus, and cognition.
Thank you, Dr. Bicchetti. Incorporation of predictive error. So, by introducing elements of surprise or unpredictability, brain engagement stimulates the brain's attentional systems. These predictive errors are crucial for initiating neuroplastic responses as they compel the brain to adapt to new patterns.
The brain is not a passive processor of sensory input. It is an active prediction engine, continuously anticipating patterns and adjusting its internal models. The process, known as predictive coding, allows the brain to refine its understanding of the world through contrast, novelty, and expectation.
And that's exactly what the NeuroVIZR does. So when sensory stimuli such as variable stroboscopic light or dynamic sound compositions are designed with structural unpredictability, the brain is drawn into an emerging cycle of anticipation, recalibration, and adaptation.
Unlike traditional brain entrainment, which merely synchronizes neural activity to fixed rhythms, this approach fosters engagement, where structured variability prevents habituation and sustains deep cognitive involvement. The interplay between expectation and surprise keeps the brain dynamically engaged, fostering neuroplasticity, attention, and creative insight.
Thank you. Okay, so it says here, not all surprises are helpful. So we're going to show you that there's a sweet spot here. Okay, and so there it is.
The Goldilocks zone is where surprises are small enough on one hand, but large enough to catch the brain's attention. This creates the sweet spot for growth and change.
We want to thank you for listening, and we'll catch up with you in the next segment. Thank you.
Thank you.